All right, for this lesson, we're going to be talking about how to add, subtract, and multiply polynomials. So we're going to look at a few different ways, formatting. You're still doing the same process, especially when you add, subtract, and then we're going to look at some multiplication. So when you are adding polynomials, you can do it vertically or horizontally. Formatting is really just completely up to you. So we're going to look at the first question. And it says that we want to add the 3x cubed plus 2x squared minus x minus 7 and x cubed minus 10x squared plus 8. Now this one says vertical format. So vertical format just means that you stack everything in the correct order and what is like terms. So if I stack everything in the correct layout for vertical, so like if I'm looking at A, so I have 3x cubed plus 2x squared minus x minus 7. Now, I will say that when we're adding this together, it needs to be in order and in descending order. So anything that's missing, so if I had like an x cubed and went to x, make sure you leave some space, because if you have another term that's an x squared, everything's got to line up appropriately. So what I mean by that is if I have x cubed, so that x cubed is going to go under that one. But I do have an x squared, so this is going to be negative 10x squared. So that's going to go underneath that one. We can't mix up a cubed and a squared, so we got to make sure they stack up. But we are missing just the single x. So we're going to skip that space and then come down here and put the constant under that one. So basically what we're saying is we're missing this minus x. It doesn't go away, but you're still missing it. We aren't actually adding anything together. If it helps, you can put a placeholder and put 0x just to kind of make sure everything is in its appropriate spot. So once we do that, we're just going to go column by column. So we're going to do the cubes, the squareds, the single x's, and then the constant. And we're going to add those together. So technically that's a 1, so this is going to turn into 4x cubed. Then we have negative 2 and negative 10, so that's going to be minus 8x squared. Then we have negative 1 and 0, so that's just going to be minus 1x or minus x. And then negative 7 and 8 is going to be plus 1. Now for the second one, it says that they want us to do it horizontally, which just means that we're going to look at what is like terms and we're going to combine those together. So if I rewrite this, horizontally is going to be basically in the same format that it already is. We're just going to change that and put a plus sign in between it, and we're going to look for what is like terms. So we can only combine like terms together. So if I color code here, I have a 9y cubed. There is no 9 or no y cubes over here, so we can't combine that with anything. Then I have a y squared. Well, there is a y squared there, so we're going to combine that one and that one. We have a 2xy, a negative 2xy, and a 7xy, so we're going to combine those. Now we can't combine an xy and a y squared because they're not the same. This is technically y times y. This is x times y. They're not like terms. And then finally, I have a 1 and a negative 4. So I'm just going to start with the 9y cubed. And then I have 3y squared and negative 5y squared. So that's going to give me negative 2y squared. Negative 2xy and 7xy is going to give me 5xy. So remember, when you combine like terms, you're only actually combining the number, the coefficient in front of the variables. And then minus 3. So those are both ways that you can stack them on top of each other and add, but just make sure that if you're missing anything that you leave space for it, I guess you could say. So like for this one right here, this would get stacked under this one would get stacked under here, and that gets stacked, but there wouldn't be anything in this spot. Okay, so just keep that in mind however you choose to do it. Now, subtraction is very similar. The only difference is that you got to remember that you're subtracting and you got to subtract every term. So the vertical format. So my vertical format, I have 3x to the third plus 2x squared minus x minus 7, and we're going to subtract here. So I'm going to put subtraction. And with that subtraction, let me move some of this over. So this is A. When I subtract that, I got to make sure that I'm subtracting every piece. So if I'm lining it up, because it's actually very simple, or it's the exact same problem, the only difference is we're subtracting this time. So I have x cubed here. I do have a negative 10x squared. Now I did not have a x, so you can put 0x if that works and you want a placeholder there. And then my plus 8. Now, personally, what I recommend is go ahead and distribute the negative. So when I say distribute the negative, that means that this negative, I'm going to go ahead and distribute that to everything in that parentheses so that I don't mistake anything and mess up. So when I do that, what's going to happen is that's going to become a negative x cubed. That's going to become a positive 10x squared. Obviously the 0, that's not going to matter, but then this is going to become negative x, and then that's going to turn into plus. So right here, I'm just going to write distribute subtraction as a negative 1. Okay, and then just go column by column. So I have 3x cubed and negative 1x cubed, so that's going to give me 2x cubed. So then I have 2x squared. So I have 2x squared, and now it's positive 10x squared because we distributed the negatives, so that's going to become 12x squared. That negative x and the zeros, so that's still going to be negative x. And then negative 7, and it's going to be negative 8. So remember, we put a negative with that 8, so that's going to be negative 8, so that's going to be minus 1. Okay, so same thing would apply if we did it in a horizontal format. So if I have 9y cubed plus 3y squared minus 2xy plus y, we're going to be subtracting 7xy minus 5y squared minus 4. And again, I would distribute that negative, that subtraction sign, as a negative 1. And then that's going to make this a negative 7xy, a positive 5y squared, and a positive 4, and then just change that to addition. And then I combine like terms. So my like terms here, we don't have a 9y cubed, so that's going to stay the same. We do have like terms with the y squareds, but I have positive 3y squared and positive 5y squared, so that's going to be 8y squared. All right, then I have xy, so that's going to be negative 2xy, and now it's negative 7xy, so that's going to make it minus 9xy. And then finally I have a 1 and a positive 4, so that's going to be plus 5. So whenever you have subtraction, you can always convert subtraction into addition. Just distribute the subtraction sign as a negative 1. All right, so multiplying is a little bit different. So when we did adding and subtracting, we combined like terms, we identified which ones had the same variables and exponents, and we just added the coefficient. But when we multiply, multiplying is a little bit different because of the fact that we actually have to combine any of the variables together. So we wind up adding the exponents of the variables. So basically what that means is if I have y squared times y cubed, or excuse me, x squared times x cubed, that's technically x times x times x times x times x. So if we put these all together, that becomes x to the 5th. So we add the 2 and the 3 to give me the 5 when you're multiplying. So for some of these, I'm going to use a certain organizational tool. If you don't feel like you need that, that's fine, completely up to you. So when I have just a monomial, which is a single polynomial with no adding or subtracting, and I'm multiplying it, we're distributing here. So we're going to distribute the 4b to the 2b, or cb, and then the 4b to the zd. So this is going to be 4, but right here I have a b and a b, so that's going to turn into cb squared, And then I'm going to do the 4b times the ZD. Now, none of those have the same lettering, so that's just going to be 4ZD. So if you don't have the same letter, you can't combine. You just write them side by side. Now, for B. Now, B is a little bit different because of the fact that we have more pieces. We have bigger than just a monomial. So when I do these, I like to use the box method. So what I do is I say, okay, for this first parentheses right here, I have 1, 2, 3, 4 terms. And then for the second one, I have 2 terms. So in my box method, I'm just going to create a box or a rectangle, just something to kind of label it. And I know that I have 2 terms on one, and it doesn't matter which side you put them on, and I have 4 on another. So I create columns and rows to match up with the number of terms that I have. So for my 2, I'm going to take this x and I'm going to make this -7. So this was the x minus 7. I split that up. And then over here, we're going to split this up, and we're going to make this column the 3x cubed. The second column is going to be the 2x squared. Then we have -2x, and then +5. And basically what we're going to do is we're going to go column by row and multiply everything together. So remember, there is a 1 in front here. So we multiply the 1, or the numbers, the coefficients, and then we add the exponents as long as they match. So this is going to become 3x to the 4th, because there's 1x here and then there's 3 there. So then I'm going to go to this one. So we're going to multiply those together. So that's going to be 2x cubed, because we had an x on the 1 and then 2 x's on the 2. So then we got -2x squared, and then 5 times 1x is just going to be 5x. There's no x's to combine together, so we're just going to bring that 1x over. Then I'm going to go to the next row. So this is going to be -21x cubed, because that x cubed didn't have anything to combine, but it's still there. Then I got -14x squared, 14x, and then I've got -35. Now at this point, I'm going to look for anything that's like terms that I can combine together. So the x to the 4th, there's nothing there, so we're just going to bring that down. But then I have x cubed, so we're going to combine those together. So that's going to become -19x cubed. You don't add the exponents, you're just combining them like we did when we were adding or subtracting. So for this one, I got -14x squared, -2x squared, so that's going to be -16x squared. And then here I got 14 and 15, so that's going to be 19x. But then the -35 doesn't have anything to combine, so I'll leave that as it is. So same thing can apply. C is very similar to the one we just did. The only difference is the amount is switched around. So we're just going to set it up. I'm actually going to do it the long way this time, just so you can see it. It doesn't really matter what way you do your box. Just so, as long as you do the same amount of numbers for each term. So we got 1, 2 here, and then we got 1, 2, 3. So we have 2, and then 1 and 2. And they don't have to be perfect, even though I'm probably going to adjust mine just a little bit, as long as you're able to section it off. I'll move this down. Alright, so for the 2 side, we're going to put m and 5. And for the 3 side, we're going to put 2m to the 6, -3m to the 2nd, and then 5. And yes, that is a -3m. That subtraction makes it negative when we're multiplying. So remember, this has just 1m, so if we multiply that, there's a 1 in front. So that's going to be 2m to the 7th. 5 times 2 is 10. There's no m, so it's just m to the 6th. Then the next one is going to be -3. I have m squared and m, so it's going to be m cubed. -5, 3 times 5 is going to be -15. No m, so we just put m squared. Then we got 5m and 25. And then, of course, we're going to look for any like terms. So if if I'm looking at this, I have a 7, a 6, a 3, a 2. So we actually have no like terms here. So this is going to be 2m to the 7th plus 10m to the 6th minus 3m cubed minus 15m squared plus 5m plus 25. So that wound up being an extremely long polynomial because there was no like terms that we could combine together. So just keep that in mind, especially when you wind up having a bunch of terms that are missing pieces. So we went from 6 to 2, we're missing the 5, the 4, and the 3. A lot of times you won't be able to combine there, but always check. Now, if I have a parentheses and that parentheses is squared, that just means that we're writing that parenthesis twice. The identical parentheses, just like if I have x squared, that's x times x. So a parenthesis squared means I'm going to take the same thing and multiply it twice. All right. So again, I'm just going to set this up. There are like special rules that you can learn to supposedly write this out faster, but honestly, by the time you remember the rules, it's just as fast to just go on and multiply everything out. All right. So I have 9y times 9y, so that's going to be 81y squared. 9y negative 2 is going to be negative 18y. We got another negative 18y, and then we have positive 4. So we are going to combine our like terms, which are the negative 18y's. Both of them are negative. So this is going to become 81y squared minus 36y plus 4. All right, and then of course what happens when we have more than one set of parentheses. So if you notice right here, I have 3 parentheses that I need to multiply together. Well, you can't do it all at one time. So what you need to do is you need to pick 2 of them, multiply it, and then once you get that polynomial, then you'll take that polynomial and multiply it by the third. So what I'm going to do here is it really doesn't matter which 2 you pick first. I'm just going to start with the first 2, and I'm going to multiply the first 2 together. So I'm going to box that. And again, you don't have to box it if you don't want to. I just use it to keep everything organized. I find students make less mistakes when they do. All right, so we're going to do x and 4, and then we're going to do 2x and negative 3. All right, so remember there's a 1 there, so that's going to become 2x squared. 2x times 4 is going to be 8x. Negative 3 times 1x is negative 3x, and then negative 3 times 4 is negative 12. So we're going to combine our like terms. So our like terms here are negative 3x and 8x. So we have 2x squared plus 5x minus 12. Now, if you remember, that was just the first part that we found. We now need to take that and we need to multiply it again by the 3x plus 5. And again, it's all about how you want to do it. I would set, personally, I'm going to set up another box. You don't have to, but you do have to make sure that you multiply everything in one parentheses by everything in the other. So it just makes sure that you are multiplying everything together. So for the first one, I have 3 terms. For the second one, I have 2 terms. So this is going to be 2x squared. This is going to be 5x and negative 12. And then this one's going to be 3x and 5. So this is going to be 6x cubed, 15x squared, because remember there's a 1 and a 1, so there's 1x and 1x becomes x squared. So that we have negative 12 times 3, that's going to be negative 36x. Then 5 times x squared is going to be 10x squared. 5 times 5x is going to be 25x. And then 5 times negative 12 is going to be negative 64. Whoop, no, that's not. That's actually going to be negative 60. I don't know what I was thinking right then. And then we're going to look for like terms. So I have some like terms. I have the x squareds are like terms. I have the x's. So my final answer is going to be 6x cubed. So I'm going to add the 10x squared and the 15x squared to give me 25x squared. Then I'm going to add the 25 and the negative 36, and that's going to give me negative 11x. And then there's nothing to combine with the constant negative 60. So my final answer is that polynomial. If you have any questions, please don't hesitate to contact me and ask.